some people weren't quite paying attention to the directions on this one. So the histogram below shows the scores earned by students in their algebra semester tests, which is their finals. And then the directions here say write a question about the final scores, not just anything I want to, not about retakes, not about anything else, about the final scores that are shown here that I cannot answer using the histogram. Now, I went ahead and typed in here, because it's kind of hard to write, a couple of perfectly legitimate options. I'm not saying they're the only ones, but they're reasonable ones. What's the mean score, the mean of the final scores? Well, since I know the ranges of these scores, I know that there are two scores that were between 50 and 59. But I don't know exactly what they were, so I can't actually calculate the mean of the final scores. I also don't know, for example, if any student scored 65. I know that 6 students scored from a 60 to a 69, but I don't know within that range of scores who scored what. It might be something about the final scores that some people put that was reasonable was, did girls score better than boys? Well, again, this is just scores of students in general. I don't know who individually scored what, but that would still be something about the final scores that might be reasonable. A general statement about the scores. One possibility. 13 students scored in the 80 to 99, oops, that should be 80 to 89. Please change that. 80 to 89 range, not 80 to 90. Then the next bin starts at 90, so this one stops at 89. If 60 is passing, which we assume it might be, but we don't know, if 60 is passing, most of the students pass the test. Now, some people wanted to put in here about how much students studied or something. This histogram doesn't say anything at all about whether they studied or how long they studied or how much they studied, where some people also got themselves into a little bit of trouble. This would be a reasonable thing. More students score between 80 and 99 than in any other 10-point range shown in the graph. And I say 10-point because if you actually look at this, if you count 80, 81, and again, this should be an 89, not 99. I don't know what I was thinking here. Some people said most students scored between 80 and 90. Well, no. Only about 14 students scored between 80 and 90, so from 80 to 99. And if I just look at the top next two, I have about, actually, sorry, this would be about 13, not 14. So I have 13 students who scored there. I have 9 students who scored here, and 5 who scored here. So putting these two together, it's already more than that. I understand what you mean. That's the tallest bar here, but that's still not most. If we have 100 people, most of them, if I want to talk about most, it's got to be more than half. So more students scored between 80 and 89 than scored in any of the other bins, but not most. Now, when I look at this next piece, it's actually giving me a dot plot. Some people wanted to say that there's a value here of 8. So when they went and found their range of the data down here, they said it was 8. But if I look, there's no dot at 8. So the range is the maximum score, well, there was a 7, minus the minimum score, there was a 0, and you always show your work, so 7 minus 0 is 7. And it really should be labeled siblings. I wasn't counting off in this case for not labeling it. So the 5-number summary for the data. Well, I can tell already that the minimum is 0 because the lowest dots are at 0. And I can tell that the maximum is at 7. But I need to find the other ones. If I want to, I could list these values out. There are 2 zeros, there are 3 ones, and it doesn't hurt to do this. So there are 2 2s, there's a 3, there's a 4, and there's a 7. That's what that dot plot's trying to tell me. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values there. So my median, 1, 2, 3, 4, 5, is between those two. So I need to show some work, as always, for my median and tell what I'm showing the work for. My median is going to be 1 plus 2 divided by 2, which gives me a median of 1.5. Now, Since there are 5 values in the lower half of the data, I just need to find the middle one, which means my first quartile is 1. And the middle one here means my third quartile is 3. That's my 5-number summary. My minimum, my first quartile, my median, my third quartile, and my maximum. So they want the interquartile range. That's the third quartile minus the first quartile. And the 3 is not because it's third quartile. It's because that number's a 3. And I end up with 2. Is 7 an outlier? You have a calculation for this. You're not eyeballing and saying, yeah, it looks like it's way out there. I can actually calculate to find if it is. I have my interquartile range is 2, so 1.5 times my interquartile range, and the 1.5 is not because that's the median, it's because the formula is 1.5 times the interquartile range. So 1.5 times 2 is 3, and that's not part of the part on the left. So I take the first quartile and I subtract 3. So 1 minus 3 is -2. No, there are no values less than -2 here, so there's not an outlier there. But if I take the third quartile and add 3 to it, 3 plus 3 is 6. So yes, 7 is an outlier. And then it says explain why or why not. And again, my explanation is not just because, gosh, it's pretty far out there. It's because it lies more than 1.5 times the IQR above the third quartile, so Q3. That's my explanation. Now, you didn't actually have to specifically give the values here for your 5-number summary. It's not a bad thing to do. And if you didn't, I might have made a note that, but it really wasn't the required part. But you had to have some really good explanations here. So, it said to describe the relationships among the numbers in the 5-number summary. Picking 2 box plots. Compare the range, interquartile range, and medians of the scores. What does this say about the engines? These box plots are kind of sideways compared to what we're used to. So here's my minimum, here's my first quartile, here's my median, here's my maximum, and here's my third quartile, and here's my maximum. Now, I don't want to leave those up there, but if I went to the side and looked at that, but just glancing at the boxes, I can tell some interesting stuff. Now, I compared all 3 of these because you had to pick at least 2 and talk about them, and depending on which 2 you picked, you're going to have some slightly different stuff. So compare the range, interquartile range, and medians of the scores from the 2 engines. The 4-cylinder car had the largest range and the largest interquartile range. The 6-cylinder car had a smaller range than the 8-cylinder car, but had a larger interquartile range. The 4-cylinder car had the highest median miles per gallon, followed by the 6-cylinder, then the 8-cylinder. So I'm talking about the ranges, the interquartile ranges, and the medians. So what's this say about the engines? Some people said the 4-cylinders are better engines. Not necessarily. They don't necessarily have more power. Some people said the 4-cylinder cars can go further on a tank of gas. Not necessarily. The larger ones have a lower mile per gallon on average, if I look at the medians, but if they have larger tanks, they could still go as far. But what I can say for sure about the engines is this. While the 4-cylinder cars have the highest miles per gallon overall, they also have the most spread. There should be some, instead of come, overlap between the 4-cylinder engines and the 6-cylinder engines, and between the 6-cylinder and 8-cylinder engines due to the spread of the 4-cylinder and 8-cylinder engines. The 6-cylinder engine is mid-range for miles per gallon and is very consistent spread-wise. It didn't have to be exactly that, but you're giving me something that shows a deep level of understanding of what this means when I look at these box plots. There is overlap, so it doesn't mean that every 6-cylinder car is going to be better than every 4-cylinder car. Most of them will be as far as miles per gallon. If you look here, the 8-cylinder cars, the best of those miles per gallon wise, were as good as at least the lower 50% of the 6-cylinders. So you're going to find some 8-cylinder cars that get better miles per gallon. Give me some good explanations.